Hello everyone. I'm starting to get into modular and I thought I'd sort of walk myself through some things I've learned and film it in case it helps others as well. I've learned a ton from watching videos like this. So I'm going to be using Euclidean circles for making rhythms and sequences, audio frequency generator from Livewire synthesizers for just making the bass sine wave, and maths for doing a whole bunch of funky stuff with those sounds and making them sound good. So I'm taking, this has 4 outputs, but I'm taking the sum of that outputs and that's going to the speakers. So first thing I'll do is I'll just take the sine wave, standard sine out from the AFG, and I'll send that to channel 2. So we can't hear anything because probably the frequency is too low, so let's try increasing that. Okay, so now we have a just standard sine wave. So let's start playing around with it. So what I'm going to do is I'm going to take a rhythm from the Euclidean circles. So this is channel 1 here. You can see it's 8 beats. Let's try to make it something a bit more regular. And so if I were to, here just to demonstrate, I'll take the output of this. This is a drum synth that basically just makes drum sound. So I can take the output of channel 1 and send it through here. Oh no, this is a channel 1, sorry. So it's making, basically subdividing 16 beats into 5 parts. So you hear 5 beats. 1, 2, 3, 4, 5. All right, but what I want to do is use that rhythm. Oops, it's too loud. I want to use that rhythm to modulate this boring sine wave. So I'll put it into this control voltage here. And so now it kind of sounds like Morse code. So it's very discontinuous, kind of like a jumpy thing. So that's where I can use maths to try to make this modulation a bit more interesting. So I'll plug this into the input of channel 1. And so you can hear it. The output of the Euclidean circles, the rhythm, that 5 beat rhythm, you can hear it here. And so one easy way to get rid of that, if I just want to hear the sound from the audio frequency generator, is to just plug into the output of channel 1. And now it's gone. So now I can use the input here. I am going to send the unattenuated output from channel 1 that's coming from my Euclidean circles. I'll send it into the control voltage here. Now we have what we had before, the kind of Morse code thing. But now I can play with the rise and the fall. So right now it's a very, like a step function, the wave. So I can make that step function and the rise be a bit smoother. So now it's like a smoother rise. Almost sounds like a whistle. So I can change the shape of that. Right now it's a linear rise. I can make it logarithmic. Or all the way to exponential here. And you can also play with the fall. So the fall is the shape of the wave when it's coming down. So now it's making a linear fall. So again, I can go logarithmic or exponential. And when it gets interesting is when you start combining the two. So here now you can barely hear the bass frequency of that oscillator that we had before. That one, it's almost gone. So I can play with the frequency here, make it a bit less annoying. So the bass frequency now sounds is a lot lower. But these modulations give it kind of this bloopy sound. Okay, and we can use another channel over here. So I have another rhythm here, and this one is in 13. So it's 13 subdivisions, so it'll give it a kind of jagged, seemingly random modulation. So I can just send it directly again to another control voltage. But again, it's very discontinuous, and it makes it it's kind of not easy on the ear. So I'll send it to channel 4 here, which also I can control the rise and fall. And then this we should be able to hear. So you can hear it faintly there, so just to make sure that the sound is not interfering, I'm going to plug it in to nothing, just so it doesn't come out. And then the unattained output of channel 4, I'll send it to this other control voltage here. And now we can play again with the rise and fall. Now another cool thing about maths is that right now this logarithmic and exponential stuff is affecting both the rise and fall. But I can change that, so I can change the cycle, hit the cycle for 4, that creates its own cycle, and now send the output of 4 into itself. So now channel 4's own cycle is controlling its rise, and now this knob here only controls the fall. Sounded kind of cool. And we can do the same actually with channel 1. So let's take this output of channel 1 that I wasn't plugging into anything, and let's send it to the fall and turn on the cycle. That sounds kind of like water. Okay, the AFG also has some frequency modulators. So let's send this rhythm here, that this one is in 11 subdivisions. So if we send it directly here, we can control the effect of the frequency modulator up here. Let's see if we can hear the difference. Okay, there we go. So this one, channel 3, is a little hard to hear, so one thing we could do is use a stackable cable here. And I'm going to send the output of this also to one of the drum sounds here, and then we'll send the audio output of this drum machine into channel 3 here. So it's a little hard to hear the drum beat. Okay, there we go. So that's the drum beat of channel 3. So I got rid of the AFG sound by plugging it into channel 2. Bring it back in there. Okay, let's try adding another frequency modulator. So we'll use channel 4 here from the Euclidean circles and send that into the second frequency modulator. Change this rhythm a little bit. And actually, let's do the same trick here. We'll use a stackable cable to go to channel 4. We'll send it here. And just so you can hear what the beat sounds like. Maybe this one. So we'll make this a snare. Let's make it a bit louder. This guy, let's make this something that's a bit easier to hear. Yeah, like a bass drum. Okay, so now we can bring in the drum beat a bit. All right, so another thing we can do, oh yeah, we wanted to add a second frequency modulator here. We can add some extra beats here. Just why not? Just trying to find a nice sound. Oops, someone changed that. So another cool thing is, so now this, here, I'm running out of cables. If I get rid of the oscillator sound and just have the drum beat, one thing that, so see, we have this little beat here. I can change the pitch manually, but what's cool is if you use another voltage to control the pitch. So we can use, let's see, let's try using this square out from the audio frequency generator to control voltage, and the control voltage we want it to be controlling the pitch. So the square out doesn't work very well. Let's see if sub out is not working very well. The problem is this is very rhythmic, so using these waves that are being slowly modulated isn't working quite as well. So if I send it, maybe this output from 3, oh, that works better. So you can make it control the, I think I prefer pitch. Okay. And now we can bring back the robot sounds. And that's it. Hope you enjoyed that.